This video we will talk about the effect of surface area of solid reactant on rate of reaction. So this will be the third factors that affects the rate of reaction. To study the effect of surface area of solid reactant on rate of reactions, we are using this equation. Remember, the surface area, we only talk about the solid reactant. Because for liquid, for gas, actually you can't find the surface area. So right here, we got calcium carbonate added into hydrochloric acid. So in the process, okay, we have some carbon dioxide produced. So this will be the experiments that you can see, okay. So in the process, okay, the independent variable, the one that we change, okay, when we do a comparison, okay, fair test, we're going to change the size of the solid reactant. The size of solid reactant, normally you will see some adjectives to describe different shapes of these reactants. So sometimes we'll use granule, sometimes we'll use lump, and then sometimes we'll have like ribbon, okay, so granule, lump, okay, and sometimes we'll use ribbon, okay, and most commonly you'll see powder. Powder should be the one we have a largest surface area, okay, tiniest, okay, amount these different kind of shapes. So independent variable, okay, it will be the size of the solid reactants. We will have one of them in powdered form, one of them will be in lumped form. Okay, so you can tell that in lump form, actually the surface area will be little, and powdered form, okay, they have more surface area, okay, larger surface area. And for the fixed variable that we have, okay, remember for the calcium carbonates that we have used, it have to be same mass. For the acid that we have used, about the molarity and also the volume have to be the same concentration and same volume. So what we're measuring this time, okay, because you're using the electronic balance, so therefore we're measuring the mass of the mixture, okay, the decreased mass of the mixture to compare the rate of reactions. So the results, okay, look like this. You can see that for the powdered limestones, okay, the slope, okay, will be steeper. Initial rate will be steeper. Lumps of the limestones, okay, it will be like this way. Okay, so you'll find that powdered limestones, okay, will have a higher initial rate, and also because higher initial rate having the same amount of products to be formed. So you can see that the end point comparing to the lump form, okay, it will end earlier. Okay, so the reaction end earlier for powdered form. So basically, we will know that increasing in surface area, increase in surface area will increase the reaction rate. So using collision theory, we try to explain, okay, why the surface area will affect the rate. Basically, you can see in this picture, okay, if you are in a lump form, only these surface, okay, only these surface can have collision with another reactant. But okay, if you break it down into smaller pieces, okay, each of the small pieces, they have a larger surface area. The total surface area allowed for the reaction to occur will be greatly increased. So therefore, when the surface area increase, chance to collide will also be increased. When there more chance to collide, okay, the number of effective collision per unit time will also increase. Therefore, the reaction rate will anticipate a higher reaction rate in this one. So have a look of the examples, okay. So right here we are having 1.5 gram powdered calcium carbonate, okay, and this is the acid, okay, and it is in excess. So the volume of gas produced, okay, given off was record. We are measuring the volume of carbon dioxide produced in the process. So we have volume time graph. So A, write an ionic equation for the reaction between calcium carbonate and also hydrochloric acid. In ionic equation, acid have to be present in H+. Calcium carbonate is a solid one, so you will have calcium carbonate with the acid. So you know that the Ca will become Ca2+, so the ratio have to be 1 to 2 like this one. Okay, so this is the ionic equation. So from the graph above, okay, find the actual volume of carbon dioxide collected at the end of the reaction time. So basically, it will be here all the way up to here, the distance, okay, between this. So roughly around, okay, is 275 cm cube. So you just read from the graph. So given that the theoretic volume of carbon dioxide gas produced is 360, so it is far more than the experimental one 275. So we're going to compare the actual values and the theoretical values, okay, suggest two reasons, okay, that cause the discrepancy found, okay. So we're going to find out why less carbon dioxide is produced. So the amount of the product, okay, have to be depends, okay, on the number of the amount of the limited reagent. So in this case, the limited reagent is about the calcium carbonate. So one thing, okay, about calcium carbonate, all the times, okay, it may contain some impurity in it. That means this 1.5 gram may not necessarily be pure calcium carbonate. So this one is very important that you have to be concerned about. So basically, one of the reasons is, okay, the calcium carbonate that we have used, okay, is not pure, not 1.5 gram, all of them belongs to calcium carbonate. It may have another impurity. That is number one, okay. Powdered calcium carbonate use is not pure. This is the first reason. The second reason, okay, will be easier for you to know, okay. That will be carbon dioxide. Remember, carbon dioxide is a soluble gas. Even it is not as soluble as the sulfur dioxide, but it's still, okay, quite good at dissolving in water. Okay, so remember, CO2 dissolve in water, they will form weak acid, which is carbonic acid. So therefore, in the process, the sum of the volume of carbon dioxide produced, okay, this is easy, it may dissolve in water. Okay, the carbon dioxide may dissolve in water. So this is another important reason, okay, for not having the exact amount, okay, of the theoretical volume of carbon dioxide mentioned there. Okay, part D, sketch another curve which is obtained by using same amount of calcium carbonate lumps this time. Okay, it's not using powdered, and we know that same mass, so that means same mass, same amount of products. But this time we are using lump. That means that, okay, the reaction will be lower because we have decreased the surface area, so the rate, okay, will be decreased. Okay, so lower rate, okay, that means less steep slope. Okay, so you can see that, okay, we are using less steep slope to less steep slope, and also end later comparing to the original one. Okay, this is end later, so therefore we have a curve, okay, like the one mentioned here. Okay, part B. Okay, so last one, suggest and explain two other properties of the reaction mixture that can be measured in order to investigate the rate of reaction. So basically here, okay, you can see quite obvious, okay, other than the CO2 volume we can measure, other than the CO2 volume can be measured, but also, okay, you can measure the decrease in mass, and also you can measure the increase in pressure, okay, in the reaction mixture, because CO2 is the only gas product. Okay, here no gas product, so therefore the pressure will increase. Okay, and also, okay, you can measure the CO2 after escape from the reaction mixture. The total mass of the reactions, okay, or of the container, okay, have to be decreased. Okay, so basically you can refer to part E to see all these answer. So two ways. One is only gas products. Okay, so therefore measure change in pressure by using pressure sensor, okay, at radical time interval. The other one, okay, allowed carbon dioxide to escape, mass will decrease, so therefore we can measure the change in mass of reaction mixture with using the electronic balance. So summary for this video, okay, so we learned that the effect of surface area of solid reactants on the rate of reactions. We learned that, okay, we'll change the size, okay, we'll change the size of the solid reactants. Okay, normally we'll use lump or granule, okay, they are the same, against powdered. Okay, so powdered one should have more larger surface area, so therefore the chance to collide will increase, number of effective collision per unit time will also increase. You have to also know that, okay, what kind of fixed variables, okay, we are having in the comparisons in the fair test experiments. Okay, so we are measuring mass of mixture for this one, so the experiments, okay, we are using these equations. Okay, so we can see that the results, okay, the powdered limestones, okay, they will generally have a higher initial rate and end earlier. Okay, so this is the effect of powdered reactant. So to explain the collision theory, remember when the surface area increase, chance to collide will increase. So again, number of effective collision and the rate will also increase. Okay, so that's all for this video. Bye bye.